All right, so let's dive right into HF radio propagation. It's all about how radio waves travel through the Earth's atmosphere, specifically the ionosphere, which is this ionized layer high above us. And this ionosphere, well, it's really interesting because its level of ionization can basically make or break your radio communication. Now, the ionization of the ionosphere is heavily influenced by solar activity. When the sun's active, and by that, I mean more sunspots and all, there's more ionization. And this, in turn, really enhances how well the ionosphere reflects radio waves back to Earth, which means better signal strength and coverage. On the flip side, during periods of low solar activity, what we call solar minima, when there's fewer sunspots, the ionosphere doesn't reflect waves as effectively. And that, well, honestly, it makes global communication quite a challenge for us ham operators. Sunspots are key here. They kind of act like little markers of solar activity. The more sunspots there are, the better the ionosphere behaves for radio communication. It's why we get so excited about solar maxima, those peaks in the sun's activity cycle. They really create these, ideal propagation conditions. And this cycling of solar activity, it's not random. It moves in a pretty steady rhythm every 11 years or so, give or take. For us radio hams, these cycles are important because they influence the frequencies we choose to use, especially if you're aiming for long distances. You've got to be strategic if you want the best chance of success out there. Let's talk about these solar indices that really shape how we approach radio communication. I'll start with the Solar Flux Index, or SFI. It's measured in solar flux units, and you'll often see it linked to ionization in the F2 region of the ionosphere. The higher the SFI, the better the conditions for high-frequency propagation. It's almost like having a stronger spotlight for your signals, lighting up the airwaves more effectively. Related to that is the daily sunspot number, or SN. Now this one's kind of simpler. It's literally a count of sunspots, but it's crucial for us because it also correlates with better propagation conditions. More sunspots, better reflection of radio waves. It's why these two indices, SFI and SN, go hand in hand for predicting how well we can communicate. Then we have the geomagnetic indices, starting with the K index. This measures geomagnetic disturbances over 3 hours. If that K index creeps above 3, it usually means propagation conditions are going downhill. And following that is the A index, which is more of a 24-hour average. It works kind of like a broader picture of the same thing. Lower A index numbers are what we aim for because higher ones can disrupt the ionosphere and mess with, signal quality. All right, let me tie this to a real scenario. A few years back, we had a major geomagnetic storm. K index spiked dramatically. Everyone in the ham radio community felt the impact. Long-distance communication became this, uphill battle as signals scattered unpredictably or even failed outright. It was a reminder of how much we rely on understanding these indices to anticipate and adapt. You've got to, stay vigilant, watch those numbers, and shift to the most suitable bands when things get turbulent. Another key tool for us ham radio operators is the maximum usable frequency, or MUF. It's basically the highest frequency that the ionosphere can support for a radio wave to travel a specific distance without skipping off into space. And what's cool is that this MUF data gets updated really frequently, often every 15 minutes, in places like Boulder, Colorado. That's huge, because communication conditions can shift quickly, and keeping an eye on MUF helps us choose the most reliable frequency for our connections. Now this brings me to some of the fantastic online resources available. You've got real-time propagation charts, interactive maps, and detailed snapshots of current solar conditions, all tailored for amateur radio operators. Sites like SolarHam or similar platforms provide tools that, honestly, I'd say are indispensable. They let us predict openings in specific bands or regions, even during less than ideal conditions. And here's something kind of fascinating. The engagement metrics from some of these tools show how connected and passionate the global ham radio community is. We're talking thousands checking charts daily, sharing observations, and working together to troubleshoot propagation challenges. For instance, during solar minima, you often see a spike in activity on resources tracking lower bands like 40 or 80 meters. It's this collaborative effort that makes operating feel like you're part of something much bigger, you know? So these real-time data tools and the vibrant community relying on them, they're not just about making contacts, they're about adapting, learning, and thriving in the ever-changing landscape of radio communication. And on that note, we've come to the end of today's discussion. Thanks for tuning in. Keep watching those solar indices, stay active on the bands, and most of all, enjoy the magic of ham radio. Until next time.